it was, I think, the norm to talk about best model and having access to the best model at the very beginning. I think everybody thought that there was going to be a best model, and we kind of, if we had just access to that, things will be solved. Suddenly, 6 months later, there was a new best model. 6 months later, there was a new best model. So I think people who have been building AI applications in general has been lacking peace of mind for quite a bit. And as the application stack evolved, we kept, this happened to ourselves as well, but we also heard this a lot from customers and open source community. As the application stack evolved, having clean abstractions in the application stack became harder and harder. And then performance comes up as a clear need in all conversations, so I'll dive into that a little bit more. And data and model proximity is something that a lot of the enterprise customers care about. I feel like this is, when it comes to smaller scale applications or startups in general, it comes up more later more in later stages than at the beginning. But I'll still touch on it as well. So this is basically our model garden today. So as I mentioned, we have recently added frontier models to the model garden, and what I touched on a few seconds ago, the common advice started with being, choose your model that best fits your task, your cost goals, and you're good to go. This actually led to a lot of people talking about approvals for a specific model family. But I would say now it is clear that it gives much more of a peace of mind to be able to say, no matter the task that you're interested in, the best model for your task should be available wherever you're looking at. So we have been sort of operating with this principle in mind, and basically not picking based on a snapshot of where things are and saying, okay, this is the best model, so we should be using this for coding, or we should be using this for text to SQL, etc. These all evolve pretty fast. And I would say, even in a specific task, when it comes to SQL, for example, we run a wide variety of evaluations, and some concepts, some models are better for than others, but they fail at, even if it's the same language, other concepts in the same language. Another thing here is things do continue to get better. Like, this is not to say things have been sort of, I think there's a common meme of prototypes work great, but as things get more complex, things fail. I feel like it's never as easy as that. There are applications, there are use cases that are getting addressed, even if they are complex, but our notion of complex use cases being addressed doesn't necessarily map with what happens at large. So this jaggedness of the experience has been there for a while, and I think it's going to be here to stay as well. When this happens, I think models that are great for a task will keep evolving. So we'll keep playing this dancing chairs of best model for task X for a while. So given any task, having the peace of mind to have access to all models does matter quite a bit. Another thing we have been hearing is, independent of what, for example, an enterprise use case expects, there has been an explosion of changes in consumer, and everybody's personal experiences are very much warped by what people experience in ChatGPT or Claude or any other consumer application. Then that dictates expectations of what LLMs should do or can do in an enterprise setting or in an AI application. Lots of prototypes do start with OpenAI and Anthropic. And when developers start in OpenAI and Anthropic, this is, again, based on feedback we've been hearing, the standard experience is very, very smooth and easy. So you log in, you give your credit card, you get an API key, you're good to go. You can start building very quickly. In general, this is not the same when you move to cloud. There are very good reasons for it not to be the same as well. But also, we have been asking ourselves, what are the aspects of this flow we can replicate for developers at large? Even if the scale goes up, do they really have to deal with all the complexities they see in a cloud environment, for example? One thing that comes up quite often is, again, people start from OpenAI and Anthropic, and the OpenAI's SDK has been used quite a bit. And I feel like at the very beginning, there was a lot of opinionated takes on what an LLM application SDK should have and how they should behave. We initially had a lot of different variations. Our Cortex APIs actually had a few tweaks of our own as well. We got opinionated and said, okay, let's do things this way and that way. But more and more, this started with Anthropic and Vertex AI, as far as I can see. Then I've seen examples in DeepSeek and VLLM as well. People have been talking about an OpenAI SDK compatible version of their API. OpenAI themselves actually recently released a responses API that is a bit more for building agents, and even for that, they've sort of used Chat API as the main basis of the spec. So based on this, for example, one thing we have come to like conclusion for was changing our APIs so that they are OpenAI SDK compatible, which mainly means it should be easy for you to move from an application that was written with the OpenAI stack without changing any of the code, by just changing your API key, your base URL, and if it's applicable, changing the model name as well, and then you keep everything else. Especially from moving to from a prototype to an MVP, I think this makes it much more easier to test things out, even if you're changing the model. And again, we've gotten feedback that this is one of the most important things, essentially a must-have, before we even come to talking about performance. When it comes to performance, so there are a couple of different dimensions. When it comes to frontier models, there are not a lot of knobs, but the availability and uptime comes up a lot in our conversations. We hear a lot about getting throttled being an issue, and we've actually, so our infra teams basically focus on using the economies of scale in our advantage so that we can distribute that to our customers. And I don't think there is a very easy solution for this in the short term, because the models are getting, even if they are not necessarily getting bigger, they are getting more complex. We are talking a lot more about multi-model input, multi-model output these days, which increases the number of tokens in the context window quite a bit as well. So I think challenges around uptime will be here to stay. One thing we have sort of learned to do better at is essentially managing different SKUs of the same model, depending on the workloads that we are seeing, and routing the traffic to the right place. This can be done much more for OSS models. So we have a dedicated team on working on inference optimization technologies. I'm going to touch on a few of the things that they have released recently. The first two of these we have actually productionized as well. They also happen to be open sourced. They are a part of VLLM stack today. You can also apply them to any open source model of your own through open source code snippets that we have released as well. They're also available in Hugging Face as well. Like some of the trained models for using these technologies is available in Hugging Face as well. So I'll share links for those as well. The first one of those is what we are calling SwiftKV. SwiftKV starts with a realization that most of the LLM inference for agents is very input heavy. So most of the time, there is either a very long set of instructions. Sometimes when we are talking about coding assistance, for example, there's a whole bunch of code snippets that you retrieve. In general, 10 to 1 is a good ballpark number that we see very commonly in workloads. In these situations, there is a very compute-heavy prefill stage, which is the first stage where you're essentially interpreting the prompt. Then there is the decoding stage, which is the token by token generation after the prompt interpretation comes later, essentially. So the team focused on prefill at the very beginning and looked into reducing the memory footprint and the compute needed for prefill. So this ended up being a 3-stage process that reduces compute by 50%, and this also increases throughput up to 2x. And again, we have applied these technologies to Llama, for example, and released those models in Hugging Face. Also, SwiftKV is implemented in the LLM open source repo as well. And we also released the Llama models that are using this technology labeled Snowflake Llama in Cortex as well. So, as I mentioned, this is a three-step process. The first step is basically saying, when it comes to prefill, most of the layers, the later layers in the stack actually don't change the KV cache that much. So KV cache is essentially the representation after before the attention layer. So in general, for inference, it is common to keep these representations as a cache. Cache is a misnomer here. If you're keeping it, most of the time you end up using it. But the one realization was, in most cases, this representation actually doesn't change in the latter layers of the model. So the intuition was, how about we actually skip the later layers when it comes to KV cache? This decreases compute quite a bit. Of course, it is also not free. So again, this is mostly for the prefill stage. So the decoding, the later token by token generation stays the same. So this is mostly for interpreting the input. When we apply this notion of let's skip the later stages when it comes to KV cache, of course there is some knowledge loss, but the result was we can actually recover this loss with a very cheap distillation, a cheap fine-tuning. So the models that run this are not, for example, if you are talking about Llama, it is not the original Llama, so you have to run this distillation process and get a different copy of the model, but it is actually a fairly cheap distillation process because you're only changing the QKV matrices here, so you're not changing all the parameters that applies to the model. And this decreases compute, but it doesn't actually do much around decreasing memory use. So the KV cache is still it still has a memory footprint. To reduce that, the workaround was in these later stages, can we actually combine the KV caches across layers? So a two-way, for example, KV cache combination basically means two layers are sharing a KV cache with with an optimized kernel that fuses operations here. You can actually get you can reduce memory consumption quite a bit, and then this translate as a significant throughput decrease, a significant throughput increase. Sorry. So you've seen 20% to 100% higher throughput. Another technology, this is actually, I think, even earlier in terms of publication than Swift KV. Speculative decoding is on the later stages of inference. So for decoding, for interpreting token by token. Here, for speculative decoding, you're using either a model or a decoding head to predict tokens ahead of time. So not doing token by token generation, but doing generating more than one token at every stage. Then the larger model verifies whether the pre-generated tokens are useful or not. And here we've actually just deployed this to our Cortex platform as well, and you can clearly see the difference in speculative decoding makes when it actually works well. So this is essentially the same model. On the left is Llama 70B, and on the right is the exact same model, just Swift KV applied. Sorry, speculative decoding applied to it. And the last thing I wanted to touch on was suffix decoding, which is it operates in the same regime, so it applies to the decoding stage. It applies an optimization to the decoding stage, but here we are actually not even depending on a model. We are building a suffix tree based on the prior conversations or outputs that you had. So if it is an application where there are a lot of common outputs, so if you're, for example, iterating on a code base and you're rewriting Python, for example, you end up repeating the same snippets over and over. In those cases, normally you would just generate those from scratch in an LLM, and you would lose that compute. With suffix decoding, you can essentially optimize cases like that quite heavily. Speculative decoding and Swift KV is, again, available right now. Suffix decoding is a published paper. The link is here. And we are planning to productionize that soon as well. This, again, will be applying it to VLLM and then also building it in Cortex. And the last thing I wanted to touch on was, as I mentioned, we hear this a lot from our enterprise customers. It comes up less in startup conversations, but there are cases where startups mention it as something that matters to their clients, so I'm going to still mention it. So all our LLMs are natively integrated to the security parameter, which basically means the data and the model operates in the same backbone. So if you're in AWS, if your data sits in AWS storage, then the model also is there. There is no public traffic, basically, as you're running inference on your data. And this becomes a key point when it comes to enterprise. I think how this translates to an AI platform and startups in general is to be able to solve for this, you end up having availability of compute across across all your network, which means you have compute availability which can come in as latency gains, for example. So in summary, we believe that all models being available through the same endpoint is actually a big sort of win for an application stack. More and more, we are using OpenAI SDK being used, so we are moving to a setup where we are OpenAI SDK compatible. I think the performance technologies I touched on, and happy to dive deeper into that as a follow-up as well. The last thing I wanted to touch on is talking a little bit about search. So we've been, again, looking at inference quite a bit and making tweaks in our inference API. The next thing that we want to dive into is evolving our search stack. And so Cortex Search has been out for a while. I think we have GA'd a year ago or so. And we have seen it used for chatbots to search applications where, For chatbots, it's the typical RAG engine. So you're leveraging semantic search, pulling documents, whether they are PDFs or other documents, then you're doing retrieval augmented generation on top of that. We have also seen quite a few cases where people used it as a backend for a high quality search bar in their embedded UI. So sometimes this is a data analytics application, sometimes it has different needs. The stack right now is a hybrid stack, so it has both vector search and a keyword-based search. This has evolved quite a bit along the way. We have added a re-ranking layer, so there's an initial retrieval that happens, then after the retrieval, there is a keyword-based retrieval here. Then after the retrieval, there is a re-ranking stage that is mostly semantic re-ranking. And right now, we are getting fairly good results with this based on our testing with respect to other sort of offerings available. A new thing we've been working on is customizing with respect to your data. So you can essentially tune your search quality based on some of the specific aspects that you want to care more for in your applications. And we are building a dedicated UI for this, so this became easier and easier to do. Maybe the last thing I want to touch on, this is I believe the Hugging Face community is actually, they are aware of this and they're very fond of it. So we have been releasing a series of embedding models for quite a bit. It is actually one of the most popular open source embedding models today. It is, at this point, a family of embedding models. So there is essentially many different sizes and also different shapes and forms, depending on the context window that you need. We have recently updated them to be multilingual as well. Now we are working on the third iteration of this, and we intend to open source this series continuously. And depending on your application, especially if you're looking for things at volume, it is actually, we see it performing better than the most common embedding models like OpenAI's embedding models, for example. One thing here about search, again, we have seen it being used for RAG applications where there is a connector from a bunch of PDFs, for example. We've seen it being used as a backend for data analytics. We have been starting to hear cases where people basically have lots of small search indices. This comes up a lot in personalized applications where there is a RAG set up, but actually the number of documents is very, very tiny. There is a namespace. There is a single user that has access to maybe 100 to a few hundred documents, but there are many, many users. Same thing with code repos, for example. When it comes to coding applications, people have GitHub repos. Everybody's GitHub repos is mapping from a user to GitHub repos is fairly easy, and each repo is relatively small as far as search indices go. So lots of writes, they keep changing, and they require fast reads because most of the time they're hooked up to an interactive application. We've been hearing this use case more and more. So if you're interested in any of these, please let us know what matters for you the most. Again, we really welcome any feedback around what is important and what is not. Just to recap, we talk a little bit about inference, having access to all models mattering, and performance optimizations, and compatibility to industry norms. Then when it comes to search, customization and hybrid retrieval, and what the use cases are that are the most important to you. That actually finishes all the material that I had. Happy to take questions.